So I'll try to cover 2 or 3 topics today. Okay, the first one will be the bounds. As you all know, it's about lower bound and upper bound. All right, let's do this one. Okay, I have, I make different types of the bounds. Okay, this is one of them. This is about 1 measurements. This involves 1 measurement. Later you'll see 2 measurements, which involve the operation of addition, subtractions, division, and multiplication. So let's look at this one measurement first. So before you find the lower bound, upper bound, first of all, you have to determine the accuracy of the measurement. Okay, accuracy of the measurement, and then get the greatest possible error. So how do you do that? Just divide the accuracy of measurement by 2. Okay, and then just get the upper bound by adding the greatest possible error. This is upper bound. When you come to lower bound, you have to subtract the greatest possible error. Okay, so you just get the lower bound by subtracting the greatest possible error. All right, let's look at this example. The length of a car is 4.2 meters, correct to 1 decimal place. Okay, for these questions, our first step is what? Determine the accuracy of the measurement. So what is the accuracy of this measurement? It says correct to 1 decimal place. So our degree of accuracy here is 0.1. The unit is meter. This is what it means. It's always 0.1, not 0.2, 0.3, or 0.5. It's always 1. Why only 0.1, not 0.01? Because of 1 decimal place. Okay, 1 decimal place. That's why the 1 is at this. You only have 0.1, not 0.01. Understand? First of all, we have to know how to determine the accuracy of the measurement. Next thing to get is GPE, greatest possible error. This is not that hard. After you know the accuracy of the measurement, just take this measurement, divide it by 2. So again, 0.05 meter. Okay, and then now I want to find out what? Let's see. Right now, the upper bound and lower bound of the length of this car. So I want to get the upper bound and lower bound. So to get the upper bound, all right, UB stands for upper bound, short form. You take the measurement, 4.2 meter. You add the GPE, greatest possible error. There you have 4.25 meter. This is for upper bound. Then we come to lower bound. You take the measurement minus 0.05. So we get here 4.15. All right, lower bound 4.15 and upper bound 4.25. All right, now this is very simple. The simple bound questions, the simplest one. And then come to this second question. We have length PCM of a car is 440 cm, correct to nearest 10 cm. And complete the statement about P. Maybe some of you still don't know what this question is asking for, right? Complete the statement about P. What statement we need to write? Well, this is again about lower bound and upper bound. Just write in inequality. Okay? Write the lower bound and upper bound in inequality form. This is the statement that the question wants. Understand? But normally in the answer space, they will give you the inequality symbol. You just need to fill up the lower bound and upper bound only. All right, so this one, again, your very first step is always get the accuracy of the measurement. All right. So what is accuracy of the measurement? The keyword is correct to the nearest 10 cm. Right. Okay. The degree of accuracy here is 10 cm. Obvious here is 10 cm. Okay. Then to get what? To get the GPE, greatest possible error. You take the 10 cm divided by 2. What you get here is 5 cm. You see? So it's not always 0.05 or 0.5. It could be 5. This one doesn't involve any decimal digits, right? So be careful here. You have to look at the accuracy of the measurement. This one is nearest 10 cm. It's not the 1 decimal place. But most of the students, they will take this one as 0.05 and then go to take the measurement at 0.05 to get the upper bound. No, that's not correct. You have to determine the accuracy of the measurement first. All right, now to get the upper bound, you just take the measurement. What's the measurement here? 440 cm. You add the GPE 5. Okay. What you get is 445 cm, right? Upper bound. Lower bound, you take the measurement 440 cm minus 5. So you get this one is 435 cm. Okay, but you can't read the answer in this way because the question asks for the statement. Okay, the way to answer it is this one, using the inequalities. So 435. Look at the symbol of inequality carefully. We have 2 different types of symbol here. Oh, you see the left one, got equal sign. The right one, it doesn't have. So the left one is actually the lower bound. The right one is the upper bound. Right? We can have the equal sign for lower bound, but not for upper bound. So imagine if this, we have, let's say we have equal sign for this. What does it mean? It will not true, right? 445, if you round off to this, it becomes 450 already, you know. So we cannot have an equal sign for this, but this one, okay. Right? If you equal 435, round off this, correct this to nearest 10 cm, you still have 440. Make sense or not? Correct this to 10 cm, you still have 440, but not for this one. This one must be less than 445. Cannot be 445. This is a limit. It can be 4.99999, still okay, right? Still less than 445, but cannot be 445. This is the first type, sum of measurements. So the steps are the same. From the beginning, it's still the same. The first few steps, determine the accuracy of the measurements, and then get the greatest possible error. And then to get a lower bound, this one is very easy. Just take the addition of the lower bounds of the measurements. You want to get the upper bound of the measurements, upper bound of the sum of the measurement, just take the addition. It's not that hard, huh? All right, let's see this one. So in this question, we have 2 measurements, a rectangle. There's a length 5.8 cm and the width 2.4, both correct to 1 decimal place. Calculate the lower bound, upper bound of the perimeter of the rectangle. Okay, in this question, this question involves 2 measurements. Here's a diagram. Here's a rectangle. We have the length 5.8 cm. This is correct to 1 decimal place. It's not the original measurements. 2.4 cm. All right. So the 2 measurements are the length and the width. Okay. Again, you need to find out the degree of, the accuracy of the measurement first. So here is correct to 1 decimal place. So 1 decimal place means what? 0.1 cm. This is the accuracy of the measurement. 0.1. All right, you get a GPE. You 1 cm divided by 2, then you have 0.05 cm. Okay, 0.05 cm. Now you can get the, let's say you're going to get the lower bound. You want to get lower bound or what? Both, right? Yes, both. So lower bound of, let's say the length. So what you do, you take the measurement, 5.8, Lower bound is minus 0.05. And you will have this 5.75. Okay, see it. How about the upper bound? Okay, upper bound of the length. Okay, again you take 5.8 plus 0.05. You have 5.85 cm. Okay, and then lower bound of width 2.4 minus 0.05. Let's give you 2.35 cm. Upper bound of width 2.4 cm plus 0.05. And you have 2.45 cm. All right. After we get all these measurements, we want to find out the lower bound of the perimeter. So perimeter, how do we get perimeter here? You know that you just need to take the length times 2 plus the width times 2, right? You have 2 width and 2 length, which are equal in length and the width. So what you're going to do here, you take the sum, right? Sum of the measurement. Sum of all these, actually. So perimeter, you want to get lower bound. Let's say lower bound first. Okay, here's the way to get the lower bound of the perimeter. So you take all the lower bound measurements, the measurement of lower bound. Okay, 5.75 and 2.35, right? So you can take 2 times 5.75 plus the lower bound of width, 2 times 2.35. So this is the sum of the measurements only. All right. So what you get this one? Two times 5.75 plus 2 times 2.35, 16.2. Okay. 16.2 cm. Okay, for the question of lower bound and upper bound, you don't need to correct this to 3SF. Write all the decimal places you have from your calculator. Don't go to correct this one. If you correct again, then you're wrong. The answer will be wrong already. Because this one is already corrected. All this corrected one. This one I want to get an actual value, I want to get actual value. So you don't go to correct this value. Understand? Get all the decimal places that you have on your calculator. Okay, then the next one is the upper bound. Upper bound, you take all the measurement of the upper bound, you have 5.85. So 2 times 5.85 plus 2.45. $16.6. Right, correct or not? Okay, 16.6. Okay. Now let's look at the one. Okay, this is about the difference of 2 measurements. Just now we learned about the sum of the 2 measurements. Now is difference. Difference will be a bit special. Okay, same. Similar to the division. Okay, a bit special. So let's see. So get the greatest possible error. You know this. Okay, determine the accuracy of the measurement, and then get the greatest possible error. Then we'll come to the lower bound of the difference of 2 measurements. This one, be careful. You want to get the lower bound of the difference of 2 measurements, you should take the lower bound of the bigger measurement minus the upper bound of smaller measurement. You see, this involves lower bound and upper bound. To get the lower bound of the difference of 2 measurements. And then you want to get the upper bound of difference of 2 measurements. This one, you should take the upper bound of bigger measurement minus lower bound of the smaller measurement. Okay, later I will explain further about this one. Okay, so let's see this. 1 year ago, IGMAT height was 114 cm. Today height is 120. Both measurements are correct to nearest centimeter. And then we've got the upper bound for the increase in IGMAT height. Okay. Here I involve two measurements. One is the today height. Another one is 1 year ago, the height for 1 year ago. So two measurements here. Okay, this involve two measurements. And when you get a difference, right? Upper bound for the increase in IGMAT height. That's the difference, right? Between the height for the current height and the height for 1 year ago. Oh, you want to get the upper bound. A lot of students will think that to get the upper bound, just take the upper bound of the today height and then go to minus the upper bound of the height 1 year ago, which is wrong. You wouldn't get the upper bound for the increase. There's a study about this. So now when you get the difference, so you have today height and the height for 1 year ago. Which one is higher? 1 year ago or today height? Today height is higher than height 1 year ago, right? So you have 120 cm for today height. And 1 year ago is 114. All right, today. 1 year ago. All right, but this value here is not the accurate one. It's corrected to nearest centimeter. So what's the accuracy of the measurement here? There's no number in this. In this statement here. Correct to nearest centimeter. It means what? If you don't see any number, it means 1. Okay? If you don't see any number, it means 1. This is actually correct to 1 centimeter. This is what it means. So 1 cm is the accuracy of the measurement. Right? So to get the GPE, you take 1 cm divided by 2. So it's 0.05 cm. So to get GPE, now you can get the lower bound and upper bound of the today height. Then this will be 195.5. 120.5. This one 199. 199.5, is it? Yeah. Okay, then how about this one? 113.5. 113. Let me check again. Be careful here because this involves two decimal places. 120 minus 0.05 should be 119.95. So good job for this. This involves two decimal places. And this will be 120.05. All right. One 113.95, is it? And it is 114.05. All right. So you have upper bound, lower bound, upper bound, lower bound. You want to find out the increase, look out the Upper bound for the increase. Upper bound means what? Maximum difference. Yes. 1 over 2 what? 0.5. Oh, there's a mistake here, is it? Oh yeah. Sorry. 0.5, huh? So just now is correct, huh? All right, thanks for the correction. And this is 113.5, okay? Okay, now it's correct, huh? So when you get the upper bound for the increase, means maximum difference, the maximum difference. How do we get the maximum difference? You can either take like lower bound minus the upper bound, right? Here is the difference you can get. Or you can get this one. You can take the upper bound of the today height minus the upper bound of the height 1 year ago. You can get this difference, which is more than this one, right? If you take the lower bound of the today height minus the upper bound of the height 1 year ago. But this is still not the largest, still not the maximum. You also can take this one minus 1, right? Still can get the difference, but still not the largest. The largest one will be what? This one. You see? This is the largest, right? The largest difference you can get. You can take the upper bound of the today height minus the lower bound of the height 1 year ago. That is the maximum difference you can get. You see, we have 4 combinations here, you know. And this will be the largest one. That's why upper bound. For the increase will be 120.5 minus 113.5. 7, is it 7? 7, yeah. Understand now? So this is something special about difference of 2 measurements. Now product is not that hard. You want to get the lower bound of the product of measurements, just multiplication of the lower bound of the measurement. This only involves 1 measurement. Lower bound, just take the lower bound. You want to get lower bound, just take the lower bound. If you want to find out upper bound, just take the upper bound. That's all. Okay, let's see this question. The sides of an equilateral triangle are 9.4 cm, correct to nearest millimeter. Work out the upper bound of the perimeter of the triangle. So this one is perimeter of triangle. And this only involve 1 measurement, right? And then you just need to times 3. It's not that hard, this one. All right, equilateral means all the sides are the same. 9.4 cm corrected to nearest millimeter. Again, what is the accuracy of the measurement? 1 millimeter, right? It says nearest millimeter. There's no number, means 1. So 1 millimeter. So GPE 1 mm divided by 2, 0.5 mm. So now you know already. So you want to get upper bound. So what is upper bound of 9.4? 9 point. Okay, let me check this one. 9.4 cm, 0.5. So 9.9. 9.9 cm. Okay, and then to get the upper bound of the perimeter, right, this is about multiplication already. Right, 9.9 times 3. But the thing is, I found a problem here. You guys see, right? This is mm. But our measurement of the upper bound here, I mean our measurement of the side of the triangle here is 9.4 cm. Okay, so the units are not the same here. So you should convert this 1 mm to cm. That will be what? 0.1 cm. So be careful here. Then only you take, okay, then only you take 0.1 cm divided by 2. Then only you have 0.05 cm. So instead of adding the 0.5, you should add 0.05. So this is not correct. 9.45 cm. So this is 9.45 times 3. Then you will get the correct answer. All right, understand this one. Be careful with the unit here because these two are different in unit. All right, now quotient. So this is another special case for quotient. Just now, difference, right? This quotient. Again, okay, you want to get the lower bound of the quotient of the measurements, you should take the lower bound of the dividend divided by the upper bound of the divisor. And then upper bound of the quotient of the measurement, you take upper bound of dividend divided by lower bound of the divisor. So this involves two measurements. So let's see this question. Okay, a metal pole is 500 cm long, correct to nearest centimeter. Okay, now you know that the accuracy of the measurement is 1 cm. The GPE 1 cm divided by 2, 0.5 cm. Okay, and then the pole is cut into roots of each length 5.8 cm correct to nearest centimeter. Here we have two different accuracy of the measurements. This is only for metal pole. Right. Another one is for the root. GP for the root. Nearest millimeter. Two different units here, be careful. 1 millimeter means 0.1 cm. 0 by 2, you have 0.05 cm. This is for the root length. So now you can try to draw the diagram. Okay. So this is what it means by the metal pole. And this pole is cut into root. Right, like this. Okay, so each root has the length of 5.8. Okay, each root has the length of 5.8. This value is corrected to nearest millimeter. And we have the length for the metal pole. .500 cm, correct to nearest centimeter. Okay, so now our question is, want to get the number of roots. One, the largest one, the number of roots. So how can we get the number of roots using these two measurements here? Okay, you should know already, right? To get the number of roots, how many roots here? You should take the total length of this metal pole divided by the length of the root. Then you will know the number of roots here. Understand? This is a very important concept. Right? So this measurement involves division. So if involve division, be careful. To get the number of roots, you know you should take something divided by something. Right? The metal pole. Okay. Of metal pole divided by the length of root. Okay. So you know that we have many choices for there are two choices for the length of the metal pole. It can be upper bound or lower bound. For the length of the circle, it can be upper bound or lower bound. So actually we have 4 different combinations here. But what we want to get is the largest one. You want to get the largest one, what should you do with the length of the metal pole, the numerator here? You want to get the largest. This one, the numerator has to be largest. Okay, has to be largest, right? And then how about the denominator? Is it largest also? No. It must be lowest. Make sense or not? Lowest the denominator, largest the result, the quotient of the division. Right? I mean, this one, if larger the numerator, the larger the quotient of the division. So you need to get the upper bound of the metal pole length divided by lower bound of the root. So what is upper bound? 500 plus, is it 0.5 or 0.05? Look at it carefully. We have 2 different GPE here. This is for the pole, 0.5. Divide it by 5.8. Since we get a lower bound, you should minus the GPE of the root. Then only you can get the final answer. I know most of you go to take the upper bound of metal pole and divided by upper bound of the root, which is wrong. Okay, 87.04. Okay, this one you cannot leave your answer in decimal. Why? You cannot leave your answer in decimal because we are looking for the number of roots. Number of roots must be in whole number. 1, 2, 3, 4, 5, right? The number of roots, how many? You cannot say 87.04 roots. No such thing. So round off this to 87. Okay, 87 roots.